So in the previous videos I have discussed with you some of the topics related to CSIR UGC NET, that are calendar clock problems, numbers, and series formation. So please go to those videos. So in this video we can discuss about the measurement of time or speed distances of an object, moving objects. So one of the question will be from this topic. So a moving object problem normally possess the challenges of finding out time taken, the speed and the distance covered while a particular object passes another. The moving object can be a train. If you, for example, you can take train, car, flight, and the object can be a truck, a man, a platform, a pole or bridge, a tunnel, a stationary train, or a moving train. So if you want to measure these parameters, then you can take the moving objects like train, flight, or any one of them, and with respect to stationary object, so you will come across some of the parameters like speed, time, and distance. So if a train crosses an object, for example, if we take train, it is crossing an object, the distance covered by train, that is equal to length of the train plus length of object. So like that you have to make the assumption. So some of the tips and shortcuts for the calculation. As we know, speed is what? Distance by time. So distance is measured in terms of meter or kilometer, and time is measured in terms of hour or second. Okay. Then we can write it as kilometer per hour. We can convert kilometer per hour to meter per second, or vice versa. So if we make the conversion, so 1 kilometer is how many meters? 1000. Okay. Then 1000 divided by 1 hour is equal to how many seconds? 60. 1 hour is equal to 60 minutes. 60 minute, 1 minute is equal to 60 second. Okay. So that means 60 into 60. 3600 we will get. So here 600 get cancel. 10 by 36 nothing but 5 by 18. You can also make the conversion from meter per second to kilometer. That will be, ratio is going to change. 18 by 8. So if two moving objects in same direction, then one is having the velocity u and another having the v. If velocity of one object is greater than other, then relative speed, if they are moving in same direction, we have to use this formula u minus v. If they are in opposite direction, u plus v, nothing but the unit is meter per second. Let us take some of the previous year questions of CSIR NET. This is the 2013 question. Two trains of length 150 meter, 150 centimeter and 150 meter and 250 meter pass each other with constant speeds on parallel tracks in opposite direction. The driver guard are at extremes of the train. The time gap between the driver passing each other and the first driver guard pair passing each other is 30 seconds. So how much later will other driver guard pair pass? So there are two trains. So in each train, one driver and one guard will be there at the extreme end, and how they are going to coincide. So there are two situations. So in first case, train 1 having the 150-meter length and train 2 having the 250-meter length. Each extreme end driver and guard is there. So case 1, they are passing in opposite direction but in the parallel tracks, opposite direction. The driver guard are at extreme ends of the train. You can see the time gap between the driver passing each other. First driver guard pair passing each other is 30 seconds. So first case is we have to draw this diagram for the first train and train 2. So initially they are at this position when time t equal to 0, t1 and t2, both the drivers are going to coincide. When time t equal to 30 seconds, so the first guard in the train 1 and the driver 2 in the train 2, they are going to coincide at time t equal to 30 seconds in case 2. So in case 3, what happens? The train is going to move further. Then here the driver 1 and second guard pair is going to coincide. So first we have to consider here, to happen case 1 and case 2, two trains together have to cover how much distance here. However, the length, if they have given, you can understand 150 meter. Okay, in case 1 and case 2 to coincide each other. So this is what the distance, 150 meter. Then relative speed, distance by time, 150 meter by 30. How much time they will take? T equal to 30 seconds. So 150 divided by 35 meter per second to coincide guard 1 and driver 2. So the next condition, both train cover a distance difference of 2 train length when the case 3, driver 1 and guard 2 coincide. That is, we have to take the difference of the length of train. So train 2 250 meter, train 1 150 meter. If we subtract, the distance covered is how much? 100 meter. Then you can find out here the time taken for the D1 and G2, that is driver 1 and guard 2 to coincide. So distance by speed, distance covered how much? 100 meter. Speed how much? Here in the case 2 we calculated 5 meter per second. 100 divided by 5, so 20 second it will take to coincide driver 1 and guard 2. That is option B is correct. So like that you have to represent graphically and then you can solve the given problem. You can find out the distance or time covered by with the help of speed of the object or the train. So second question. So this is the question from 2014 CSIR NET. There is a train of length 500 meter in which a man is standing at the rear end. At the instant the rear end crosses a stationary observer on a platform, the man starts walking from the rear to the front and the front to the rear of the train at constant speed of 3 km per hour. The speed of the train is how much? 80 km per hour. The distance of man from the observer at the end of 30 minutes is. So we need to find out the distance of the man from the observer at about 30 minutes. So first try to understand by the diagram here. So man is at the rear end of the train. Here is the man. So the length of the train is how much? 500 meter. So observer is standing on the platform. So here the rear end of man crosses the observer. So observer is on platform. So after 30 minutes, we need to find out the distance of man from the observer. So here is the and the man is what walking from the rear to the front and front to the rear of the train. Okay. So from rear end to the front to the rear. You can see here is at the front position of the man in the train. So here the speed of with what speed he is moving 3 km per hour. So then time t is equal to how much? 30 minutes they have given. That is how much hour? Half an hour. So distance traveled we can calculate by the man, that is 3 into 1 by 2, how much? 1.5 kilometer, nothing but 150 meter in terms of meter. So after 30 minutes, the man is actually at the front end of the train. Okay. So he is anyhow moving from front to back to front. So after 30 minutes, we have to calculate uh, the distance from the observer. So how much distance he is going to cover when he is moving from front to back to front? He is moving with 3 km per hour. So after 30 minutes, he is going to cover 150 meter distance. And so after 30 minutes, he is going to be at the front end. Initially, he is at the rear end, back end. Then that is 500 meter away from observer. Okay. Then figure 2, as we have drawn, distance covered by the front end of the train from the observer. Then speed of train is how much? 80 km per hour. Time is how much? 30 minutes. 80 kilometer into 1 by 2, how much distance train has covered? 40 km per hour. 40 km. So distance of man from observer at 30 minutes. How much? So train is going to cover 40 km and man is at the front end after 30 minutes, and the actual the distance from the observer for the man is 500 meter. So 40.5 km total distance of the man from the observer. Okay. So this is how you can calculate. The option B is correct here. So anyhow the length of the train is how much? 500 meter. So when he is at the front end, so he is going to cover how much distance? 500 meter, and train is moving with the speed they have given, and we can calculate the distance, that is 40 kilometer, 40.5 kilometer. So the next question, this is from 2014. The question is, two locomotives are running toward each other with a speed of 60 and 40 km per hour. An object keeps on flying to and fro from the front tip of the locomotive to the front tip of the other with a speed of 10 km per hour. After 30 minutes, the two locomotives collide and the object is crushed. What distance did the object cover before being crushed? So you can see here two locomotives. It may be train, bus or car, whatever it may be. So here they are moving with speed 60 and 40 kilometer per hour. One is moving with 60 and another with 40. An object keeps on flying. Here is the object. So it is going to uh, move from to fro and to and fro from the front tip of one object to one locomotive to the another. Okay. After 30 minutes, these two are going to what? Collide. Okay. When the collision happens, the object is being crushed. When it is moving from front to back, back to front, to and fro, then at what distance it is going to be crushed, we have to calculate. The options has been given. Let us calculate. The flight of the flying object doesn't depend on the flight of the locomotive. When it is flying or moving from one front tip to the another, it doesn't depend upon the flight of the locomotive. Whatever the two locomotives or the two train or buses, if you take, they are independent. Hence, for finding the distance covered by the flying object, the speed of two locomotives are insignificant, as their speed do not contribute to the relative speed of the flying object. So the speed of these two locomotives or trains we can take, they are not going to contribute to the flying object. So speed of the flying object is how much? Here 70 kilometer per hour. So collision happens at how much? 30 minutes, nothing but half an hour. So flying object, that is the distance we can calculate with the help of speed into time. 70 into 1 by 2, how much? 35 kilometer. So option C is correct here. And here we have the object is moving with a speed of 70 kilometer per hour. So the answer is 35 kilometer. So the another question from previous year question paper of CSIR NET: to go from engine to the last coach of his train of length 200 meter, a man jumped from his train to another train moving on a parallel track in opposite direction, waited till the last coach of his original train appeared and then jumped back. In how much time did he reach the last coach if the speed of the train is how much? 60 km per hour. So he is moving in the first train having the length 200 meter. You can see train 1 having the length 200 meter. So he is inside the first train. He is going to jump to the train 2. Okay. He is going to wait till the last coach of the first train comes, and then he jump from train 2 to his original train 1. So how much time he may take to do this? So first we have to note down here the relative distance covered by two trains, how much? Because first train length is 200 meters. So here the distance covered must be 200 meter. Relative speed of two trains, they have given here 60 kilometer per hour. So 60 plus 60, how much? 120 kilometer per hour. So 120 into kilometer 1000 hour, 60 minute into 60 second. So this if you do 5 by 18, that is directly you can calculate, and this ratio you will get 200 by 6 meter per second. So what is the formula to calculate time here? Time is equal to distance by speed. So speed, we have calculated how much here, 20 200 by 6, and the distance of the train is how much, 200. So 200 get cancelled, so 6 second he will take to reach the last coach of his original train from train 2. So option B is correct. So first you try to make or the figure out whatever the parameters they are given, and then you can easily calculate. So this is how you can solve the problems related to finding the speed, time or distance for the moving object. Thank you. Thank you for watching.